Alright, so what we're doing today is section 4.2, constructing sequences. So we talked about sequences last time, and now we're going to be really getting into the formulas. So all we're doing in this whole lesson is we're going to be talking about these formulas and how to make the formulas for arithmetic sequences and for geometric. So the equad is how can you represent a sequence as a function or an equation, and the two vocab are just an arithmetic sequence. Just means an equal difference between consecutive terms, and a geometric sequence an equal ratio between consecutive terms. Make sure you have these standard form equations down because these are the ones we're going to use. And in these equations, we need to know that A1, so A1 is our first term in our sequence. So the first thing listed, our first term. Okay, our D is our ratio, just kidding, our difference in our arithmetic sequences, and our R is our ratio, or what we are multiplying our function by. Alright, so when we look at our examples, we're going to go through and we're going to think about a couple different things. First thing we're going to think about is it arithmetic or geometric? The second thing we're going to think about is what is our first term and what is our difference. And the third thing we're going to think about is, okay, how do we write a formula? So you know what, in order to write out those steps, I'm actually going to erase this side. So if you need to go ahead and write those down, go ahead and pause the video and get those written down. I am going to erase them for space. I'm erasing these. I'm going to be just up here. Alright. So here's just some steps that we're going to be following. So we're going to think, is it arithmetic or geometric? That's the first thing we got to figure out. Then we need to identify our first term, which is A1, and either our difference or our ratio. And then we're going to use the standard form to write an equation. So these are the steps we're going to follow in all of our examples today, because in all of our examples we're working to write an equation. So this is our first example on the right hand side here. It shows it in function notation. So the first term is 58, second term is 65, third term is 72, and fourth term is 79. So we got to figure out what's the rule, right? Is it arithmetic or geometric? So what's the rule happening each time? Okay, to go from 58 to 65, we would, well, let's try just adding 7, see if that works. 65 to 72, yeah, that works. And it works again. Awesome. So what we have is we have an arithmetic sequence, meaning we're adding or subtracting something every single time to get to the next term. Alright, our A1 is always our first term. So our first term in this case is 58. And our D, or our difference, well, we just figured that out, was plus 7. So we did all the hard work, we've got all that info now, and the last thing we got to do is just plug it into our standard form equation. Remembering that we don't plug anything in for n or a of n. These are the only terms we plug in, what we just found. So we've got a of n is equal to a of 1, 58, plus 7 times n minus 1. And then we're going to simplify that out. So we can distribute our 7, and we get 58 plus 7n, 7 times negative 1 minus 7. Okay, well we have two, like terms here, we have two numbers, so we're just going to combine these two together. 58 minus 7 is 51 plus 7n. And that would be our final answer. That's what we would use to write out an equation. That's our final equation. Okay, but a lot of times we got to use the equation for something. So the problem might ask maybe what's the 1,000th term, what's the 100th term, something like that. And it would take a really long time to keep adding 7 to get the next terms, all the way till you get to the 100th term. So what we do, let's say the question asks for the 100th term. We would take this right here and we would plug in 100 for n. Plug in 100 for n. Okay, we would just simplify. This says 7 times 100. So we get 51 plus 700, which is just equal to 751. So the 100th term in this sequence is 751. Okay, I'm going to erase this so I can give you guys one to work on, so if you still need it, pause the video. Alright, so I'm going to give you guys one in the exact same format. I'm just going to give you a different sequence, and I want you to try and write the equation. You can use our steps, and I also am going to give you a certain term that I want you to find. So your sequence is right there. You're going to go ahead and follow these steps and make sure you end up with an equation. A of n is equal to something. After you get that equation, I want you to find the 50th term. Okay, the 50th term. So figure out what that is for me. Remember that since you're working this out on your own, this should be on the left-hand side. So go ahead and pause the video now and complete that on the left-hand side. Alright, if you are back with me, I'm assuming you've already got this one down. So your equation, so that you can check it out, make sure you did everything right, should be 40 plus 20n, and your 50th term would be 1040. I believe so. Right? 0 times 0 is 0, 0, 0. Yeah. Awesome. Alright, so you should get 1040 there. If that's not what you got, go ahead and try it again. Try and work it out and see where you made the mistake. We're going to do one more like this. And then we're going to look at ones in a different format and see, just make sure that we can apply this to all different formats that sequences are given to us in. So let's do some geometric sequences. So the first one we're going to look at has 6, 12, 24, and 48. Alright, so we got to figure out, we already know it's geometric, because I told you. So we're going to figure out what's happening each time to get to the next number. What are we having to multiply by each time? Okay, well to get from 6 to 12, we multiply by 2. And we just have to make sure that works for all of them. Yep, works for all of them. Cool. So we're good there, we got our rule. So our second step says we need to identify A1. That's our first term, which is 6. And D or R. Well, we have R this time. We have a ratio because it's a geometric sequence. Okay? So our R was times 2 or just positive 2. And we're going to now look at our standard form for our geometric sequences. So our standard form says A of n is equal to A of 1 times R to the n minus 1. Remember that the only things we plug in for are the things we just solved for, A of 1 and R. We don't plug in anything else. Okay, so we get A of n is equal to 6 times 2 to the n minus 1. There's some stuff we could do to simplify this, but we're not even going to bother. This is perfect. This works out great for us. So that's our standard form. That's our final equation to represent that sequence. Okay, well, just like we did in the last one, sometimes it's going to ask you to find a specific term, like the 100th term, 50th term, 20th term, something like that. We will go ahead and find the 5th term so that we can check our answer. Right? So the 5th term means that we plug a 5 in for n. Okay? And then we think about PEMDAS. PEMDAS is parentheses first. There's nothing we can simplify in the parentheses, so we can't do anything there. Exponents next. So we look up here in the exponents and we think, okay, we can simplify that. So we simplify that to 4. Well, we still got to deal with the exponent, so let's go ahead and distribute it in. So 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th power is 16. Okay, and if we multiply those, we would get that a to the 5 is equal to 96. Cool. Alright, so just like last time, I'm going to give you guys one to try on your own. I do think that geometric is a little bit easier in the sense of making an equation. I think there's not as much simplifying, not as much room to actually make a mistake. So let's hope that we can get this one. I am giving you guys a little bit of a tricky one. So we'll see what you guys can do. Okay, remember, when you work this through, I want you identifying your first term and your ratio. I want you to find your equation for me, and then I also want you to find the 10th term. Okay, Fee? I'll be nice. I want you guys to find me the 5th term. Okay. Alright, go ahead and work that out for me. Make sure you're doing this on the left-hand side. Pause the video and come back when you're done. Alright, if you're back with me, I'm assuming that you have already worked this out. So you should have gotten a of n is equal to 3 times negative 3 to the n minus 1. If that's not what you got, go ahead and make sure you go back and fix that up. You also should have got a positive here. (81) times negative 81 times negative 3, those turn into positives. Let's just see what 81 times 3 is. 3, 24, 243. If you didn't get that, go ahead and make sure you go back and figure out what went wrong. Alright, moving back to arithmetic. So we're going to look at arithmetic again, but we're not going to see it in that table format anymore. So if we go back to thinking about arithmetic sequences, we're still doing the exact same process, it's just going to look a little bit different. So we're going to look at the first sequence we're going to see is 112, 110, 108, 106, and so on. Alright, so we got to figure out, we already know, arithmetic. Cool. So we know there's some sort of difference. So we got to figure out what is the difference each time. What are we adding or subtracting each time? Okay, well it's getting smaller, so we're definitely subtracting something. And we're actually subtracting 2 each time, and it does end up working out. And since it's arithmetic, we have our standard form right here. We know that A1, our first term, is 112, and D, our difference, is negative 2. So when we plug those into our standard form, we get A of n is equal to 112 plus negative 2 times n minus 1. Okay, just like we did last time, it's the exact same process as we worked through before. We distribute to the n, distribute to the negative 1, and this is where people make a lot of mistakes. We get A of n is equal to 112 plus a negative 2 times n, negative 2n. A negative 2 times a negative 1 gives us a positive 2. And when we combine our numbers together, combine our like terms, we get 114 plus negative or just minus 2n. So there's our equation. And let's say I'm going to ask you to find the 90th term. Okay, so when I ask you to find the 90th term, that means you're plugging 90 in for n. So we got 114 minus 2 times 90. Okay, so we get 114 minus 180, which actually ends up giving us a negative number. So our A of 90, I'm going to erase this just so I have space. Our A of 90 would be a negative 56. 66. Negative 66. Cool. So I'm giving you one arithmetic sequence that you can do on your own, the exact same process we just went through, and then I'm going to give you a number to identify. So I'm already telling you it's arithmetic, so you know that you're going to be adding or subtracting something every time. And you just got to figure out what that is. Okay, there's your sequence. Go ahead and figure out what your A1 and D are. Make sure you get your formula. And then I want you to go ahead and find the 60th term for me here. Make sure you're completing that on the left-hand side. Alright, so you should, if you're back with me, I'm assuming you've already worked this out. And your formula, I'm actually not going to give you guys your formula this time. I want to make sure you can do it on your own. I'm not going to give you this one. Alright. Very last thing, we're going to look at a different form of looking at geometric sequences, and we're just going to do two of these, one from me and one from you. And these should actually be a lot easier because they're a lot easier to actually write in the standard form. Okay, here we go. 1, 4, 16, 64, and so on. So I know it's a geometric sequence. I know that I am either multiplying or dividing by something each time. And I just got to figure out what that is. So to get from 1 to 4, I'm multiplying by 4. To get from 4 to 16, I'm multiplying by 4. And so on. And it ends up working out. So for this geometric sequence, A of 1, or the first term, is 1. The ratio is 4. You're multiplying by 4 each time. So when we write out our standard form, this one right here, we plug in for A of 1 and we plug in for R. So A of 1 is 1. R is 4 to the n minus 1. Remember, that format is good. We don't really have to simplify much at all. But since there's this 1, a coefficient of 1 out in front, we know we don't need to include that coefficient of 1. So we can actually write it out just like this. And if I ask you to find the 6th term, we would plug a 6 in for n. And then using PEMDAS, can't do anything in the parentheses, so we go to the exponents, and we solve that out. We get 4 to the 5th power. I'll work this out really quick. You should get 448. Okay, one last one that you're going to do on your left-hand side, and then we're going to call this good. So we're still going to work with the geometric. I'm going to go ahead and erase this. If you need it, just pause the video. Alright, so the very last one you're working on is 3, negative 12, 48. And that's all I'm going to give you. Okay, you need to go through this same process. Make sure you end up with an equation. And also I want you to find the 7th term. Cool. I'm not going to give you the answer to this one too because I want to make sure you guys are all set and ready to go for this. Alright, so that concludes our constructing sequences lesson of 4.2.